Which of the following mechanism reactions does not occur in bromoethane? Let's have a look. Let's eliminate some. Let's get rid of some. Radical substitution. So methane can react with a Cl dot radical, a chlorine radical. So bromoethane could do the same thing. So free radical substitution could occur with bromoethane with a chlorine radical, a Cl dot. Yes, that's true. Now bromoethane, we've done back in early AS, can react with potassium hydroxide or sodium hydroxide. If the potassium hydroxide or the sodium hydroxide is in cold water, then you get nucleophilic substitution where the OH replaces the Br and it would make ethanol, and Br minus would come off. If you end up with warm ethanol, so if you put it in warm ethanol, what actually happens is you get an elimination reaction then, where the Br comes off as Br minus and an H is removed and comes off with the OH minus as water and leaves something with a double bond. It will leave ethene. The only one that doesn't occur then is A, electrophilic addition. Electrophilic addition happens when something's got a carbon-to-carbon double bond and something like a HBr or a BrBr or a sulfuric acid, a H2SO4, adds across the double bond. With the no double bond in bromoethane, it cannot do that. What's the empirical formula for 4-hydroxypentoene? Well, let's have a look. It's got 5 carbons. So pentoene has got 5 carbons. It's got a double bond between carbons 2 and 3. So at carbon number 2, it's got a double bond, an ene, and it's got an OH group. A hydroxy group is an OH group, carbon number 4. Let's have a look at its structural formula and then we can work it out from there on in. So its structural formula: 1, 2, 3, 4, 5 carbons. A double bond, so instead of CH2 at carbons 2 and 3, we've got CH. That shows there's a double bond in between there to make up 4 bonds on each carbon. We've got an OH at carbon number 1, 2, 3, 4, and there it is. OH in brackets means it's a branch off the chain. So that's the structural formula. If I work out its molecular formula: 1, 2, 3, 4, 5 carbons, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens and an oxygen. That can't be simplified. I've only got one O in there, so I can't divide by another number to simplify the number of O's. So it must be C5H10O is both its molecular and its simplest empirical formula. So your answer is B.